Okay, in the last two videos we looked at shifts, also known as translations, which is one kind of transformation or way to change a graph. In this video we're going to look at a second way to do a transformation of a graph, which is by a reflection. And in order to demonstrate this, I'm going to look at the function square root of x, and then related functions minus square root of x and the square root of minus x. Okay, so let's make a table and try and come up with what are the y values for various x values. Keeping in mind that we're talking about a square root, we're going to have limitations on our domain. There's some numbers I can take a square root of, some numbers I cannot take a square root of. For now, I am going to just leave numbers from -4 to 4 in my table. When I plug those into the original function f, square root of -4 would be an imaginary number, so I'm just going to say there's no points on the graph at that particular value of x. Square root of -3, same story. Square root of -2 and -1, again, same story. We can't take square roots of negatives. Square root of 0 would be 0. Square root of 1 would be 1. Square root of 2 would be a decimal. It's approximately 1.4. Square root of 3 is another decimal. It's approximately 1.7. Square root of 4 would be 2. Okay, so those will be some points to put on the graph. G says we take the square root and then we multiply it by a negative. So we'll have the same restrictions on our domain. We can't plug in negative numbers because we can't take square roots of negatives. When I take minus square root of 0, that would be -0, which is just 0. When I plug in a 1, minus square root of 1 would be -1. And so we're going to get the same values just with negative signs. Okay. Let's look at h of x. Every time I look at this example with students in the room, right now there's no students in the room. There's nobody here. People get confused by this and think that the domain would be nothing because we have a negative inside a square root. But that's actually a trick, because if x itself is a negative number, then this would be the square root of a positive, so that should be okay. If we're really concerned about the domain, realize that we need to make sure that minus x has to be greater than or equal to 0, which just means if you multiply it by a negative, that x has to be less than or equal to 0. So our domain for this function is actually negative numbers, or non-positive numbers. So if I plug -4 into that function, square root of -4 would be the square root of +4, which is 2. So I can actually plug in -4 into h, and I'll get a 2. I can plug in -3, and the same thing will happen. I'll get a 1.7, and -2 will give me the square root of 2. -1 will give me the square root of 1. 0, well, -0 is still 0. But once I start plugging in positive numbers for x in this formula, we'll have -1, which I can't do, and so this function kind of is reversed in terms of its domain. Instead of being able to plug in positive x's, I can only plug in negative x's, so that the inside of the square root ends up being a positive number. Okay, so I'm ready to try and draw my pictures now that we have a bunch of points. Okay, the original function goes through 0, 0, 1, 1, 2, 1.4, 3, 1.7, and 4, 2. So this is our square root of x function, which is also one of the functions that's in our collection of functions that was from section 3.2. Okay, second function g has points. First one is at 0, 0, then 1, -1, 2, -1.4, 3, -1.7, and 4, -2. Just to make this one look different, I'll use dotted lines, but I mean it's still a normal graph. I'm just trying to make it look different from that one. G of x is the square root, minus the square root of x. Okay, and points on h of x, we would have minus 4, x is minus 4, y is 2, x is minus 3, y is 1.7, x is minus 2, y is 1.4, x is minus 1, y is 1, and then 0, 0. Okay, so I'm running out of ways to make this look different. We'll do long dotted lines. Okay, so let's take a step back and look at what happened to the function from the original f to these two variations, these two transformed versions, g and h. And basically this is why we call the name a reflection. We treat the x-axis as though it was a mirror, and then the mirror image of f would be g of x. So this is actually a vertical reflection. Another way to think about what's happening in a vertical reflection, the points keep the same x values. So for instance, this is the point 2, 1.4. This is the point 2, minus 1.4. And this point is transformed into that point. It keeps the same exact x value, but the y's end up changing sign. So I could think about it in this way as y getting turned into minus y. Okay, so there's a couple of things about this that are not super surprising. One is I'm multiplying by a negative. So yes, something is going to change signs. Apparently it's y. Why does it happen to be y when the minus sign is right there? Well, keep in mind, same rule of thumb as with our translations in the previous video. Something that's on the outside of the function, so our function is square root of x, the minus sign is on the outside, which suggests to me that I'm going to find the square root first, and then I'm going to change signs, which means it's going to affect my outputs, it's going to affect my y's. So this minus sign being outside the function means this is a vertical transformation of some kind. And in this case, apparently, multiplying by negatives is some kind of reflection. So the minus sign being on the outside is a hint that this should be vertical. The fact that it is a minus sign means it is a reflection. Okay, let's look at this h of x next. You can probably guess what I'm going to say. Instead of being a mirror image of the original function from top to bottom, this time it's a mirror image from right to left. So in the previous example, it looked as though the x-axis was a mirror, and this dotted line on the bottom is the mirror image of the solid line f of x. This time I'm going to treat the y-axis as though it was a mirror, and then the mirror image of this solid graph f of x would be this long dotted line h of x. And so this is, let's see, if I again look at this particular point, he gets transformed into this particular point, which is negative 2, 1.4. And again, I'm multiplying by a negative. Something's going to change signs, but this time the negative is inside the function. It's inside the square roots, which means I'm changing my input before I plug it in, before I actually use the function. And if I'm changing my input ahead of time, that means I'm changing my x. And so in this case, h of x is going to be a horizontal reflection. Reasons we know that is that positive x's, x is 2, is getting turned into a negative x. Also, multiplying by a negative is apparently a reflection, and this one is on the inside of the function. That's a hint that it should be horizontal. So a minus sign being multiplied on the inside is a horizontal reflection. Okay, so h of x equals square root of minus x would be a horizontal reflection. Oops. And positive x's should be turned into negative x's. Okay, so again, same story as the previous material where we're looking at translations. positive. Multiplying by negative on the inside is horizontal. Multiplying by negative on the outside is vertical. Okay.